Hi all, this is Claudio from explicit.com with a new live stream which contains finite element analysis in ANSYS workbench, at this moment targeted for beginners in order to attract them in this fascinating and awesome domain of simulations. So let me share my screen. As usual, I would like to draw your attention towards my website, explicit.com, where you can find top simulations, CFD, tutorials, videos, also live support. So today we're going to talk about Seismic FEA. I will give you some small pointers. So we're going to obtain such a building, maybe closer to this one, and we'll subject it to placements in order to see the impact on the structure regarding its strength and velocity, whatever we can obtain from the FEA. So let me open a 3D model that I was dealing with it in the last days. This 3D model is this one. I took it from grabcat.com and began healing it, editing it, customizing it, and everything. You see it transparent because I made it transparent. Let's see if I can make it opaque again, just out of curiosity. Yeah, you see? We can make it opaque anytime we want. Yes, I will undo because there is a reason I would like to keep the transparency here. Firstly, let's see, as usual, let's check for interference. I have removed some of the balconies and some cosmetic details from outside of the building. Here there are some collisions, mainly due to the fact that, for example, here we have this floor which is interfering with these walls. Again, this floor is interfering with these walls, and this floor again and again. Here is kind of too much. It seems like we have two floor parts. Press the green check. Usually the limit for this operation is 250. Usually when we get 250 interfering regions, in reality it's more. But the higher limit is 250. It can repair at once only 250 interfering regions. Let's see what's the deal with this floor. For example, look here. This is something extra, yes? With control and middle mouse, we can hover between geometries that overlap. Yes, we can hover between them. Let's triple click here, and we can see that there is a floor. And this floor, sincerely, because there is no floor downwards here, I would like to move it downwards. For just out of curiosity, let's see the distance, 500 millimeters. But we should measure the distance from here, from the top surface of the floor, this one, because I would like to move it towards here. 1000, yes, 1 meter. So first thing, 1, 2, 3, triple click, and we will move it with 1 meter downwards. From the keyboard, 1 meter. So we got rid of that problem. Let's see a little what is with this. We have a floor, and we can see that some of the walls collide with this floor. Yes, so maybe now is the time to let the software deal with this. What is this? I don't care about this. I don't care about this. Sticking to what's important for our simulation. Floors, walls, and we will also model some support structure, some columns. Let's make this transparent again. All right. Right-click source internalize, and let's save it as version 3. Version 3. Any extra? What is this? Come on. For example, this thing should be pulled, no merge, should be pulled up to this edge. Yes. So which one is here? Here, for example, this should not be here. What is this? Ah, okay, it's the other side. I'm looking to see if there are walls which, look here, these walls, they are too high up, let's say. A wall that we don't need. Let's move these. Let's now merge up to this wall. Again, move these up to this wall. We don't need. Here we can see some collisions. This wall collides with this command. Let's hope they will be automatically solved. Okay, it could have been better. There is always room for improvement. What about these faces? Let's pull them up to this wall, for example. All right, these. What have we here? These three, let's pull them up to this wall. We have an extra, what is this here? An extra, what is this? We'll pull it to this wall and this one to this wall. All right, again, pull, what is this? Delete. If we are very neat and we take care of our 3D model, then the meshing and the simulation will go very, very well. If we are, how do we say, if we are partisans of quick and dirty, then most of the time, many problems will appear further on. when doing the meshing, done when applying the boundary conditions, then convergence errors appear, and so on. So this is why it's kind of mandatory to pay very much attention and be very clean. So this one, I will pull it to this face and this face to this wall. All right. And here, let's pull this here. This is a balcony. Yeah, why not? Yeah, something protruding outwards? No. Pretty nice. Whatever here, should we leave this? Why not? Should we or should we not? I don't understand why there is this portion. All right. Let's not overkill it. We have a door. I thought I removed all the doors. This is a door frame. All right. I'm looking at frames. I removed also the stairs because we want to quickly obtain results. Right-click, delete empty components. Right-click, source, internalize all, and save. Let's see if we have any from the audience. No question. Instead, greeting. Another cool simulation. Yes. Thank you. It will be cool in a while. Here are walls, and it can be dangerous for the people living here. So they should provide walls. Come on, it's not that expensive. Can I move this here? Why not? What distance do we have between this edge and this edge? 9710. All right, why not? So move, and I will write from the keyboard 9710 in order to assign a wall here, because these people, maybe they cannot afford to have a wall. Let's make a wall now. I'm feeling generous today. 1, 2, 3. Let's also go here. I'll measure the distance between this edge, and the distance is 10,500 millimeters. I will write from keyboard. All right, so generous me. I'm giving walls. And it's anonymous, because it's no one at home. You can see. It's nobody at home. We don't like to brag with our generosity. All right, so do we have any walls missing? Come on, tell me while I'm feeling generous. Here I see something missing. Do we leave it as a balcony? Let's just leave it. All right. So I was thinking about assigning support columns. Look here. Support column minutes. Yeah, these ones from the inside. So we need to make these support columns. So we need to have this. The rule, the general rule is that there should be support column when there is intersection of walls. So let's assign these columns. And I would like to see how it looks regarding. So they go downwards pretty well, because I would like to extrude them more than the bottom floor, you know. So, for example, before moving forward, prepare interference. Let's see how many interference, how many collisions do we have. At this moment. Yeah, the same thing. Let's see if we can just solve it. Here, for example, it's pretty big. What is this? There is this option, selection, faces. I don't know. I would have wanted the coincident faces, but it's not possible. All right. Pull up to, if you press U from the keyboard, you go to up to, okay? U from the keyboard. And we know this is the floor, and the wall is from this side. All right. This is nice. This is clearly extra. So it's clear, for example, it comes from a very big wall from the floor from under. So let's decrease it. Okay. Yeah, so sometimes the guys from design, they just don't care and they leave some CAD errors, some CD errors. And these errors need to be solved prior to performing the simulation. So yes, it's not so, we need so much attention. And also we need to remember this is something for tutorial purposes. Yeah, so it's not so mandatory that we are very strict. Let's add more windows here because it's free. And we like, you know, open space. We like everyone likes open space. These windows also here. Yes, something like this. With Control pressed, we copy the windows or any features in principle. We do have some isolated windows, but we're not architects or structural engineers after all. So let's give it a rest, you know. This collides with all the walls here. A small solution would be if I select all these faces and move them up to this line, and they will not collide anymore. All right. What's with these? These. Yes, this should be here, and something more. We want satisfied customers before they win, you know. They will recommend us to their friends and relatives if we are doing a good job. Why is this surface split? Delete. Why do I have this here? Let's just move it. Right. So, in principle, you know, it's not a Burj Khalifa, so maybe we can take a rest. Let's not remove this wall. Okay. We don't want people falling over. You know, they get out of the bed and they just fall over. So let's respect their integrity and their physical well-being. These are usually the lift shafts, the elevator shafts, and let's make them here. All right. Why is this here? This should be here. All right, and here again. Yeah, I know it's maybe boring for some you watching. Feel free to skip, you know. I'm showing the simplest commands to heal, to edit, and to model and spacecraft. So if you already know them or you simply don't want to waste time, just skip towards where you see more results, you know. All right. Source internalizer. Delete components, save. Let's go again with the interference. I don't like the fact that we were stuck with 250, which is kind of too much. All right, because I would like not to cut the floor, I would like to cut the walls, all right? It makes sense. So let's check here, subtract from smaller body. And I will click here. Hopefully we'll have something nice, hopefully. If there are more than 250 interfering regions, it will solve them. Then if there are more, we will see more. I mean, here we will see additionally 100, 200, 120, for example, yes? So in reality, there were 370 interfering regions, let's say. Nevertheless, I think we now have a different problem with these walls. Maybe it might be that we have double walls. Let's see, for example. I would like to hide this wall, see if it's doubled. No, it's not doubled. Do I see that this wall collides? Yeah, interesting. Very. We have only these two walls, you know? Hopefully nobody's looking. We will sell the apartment with the discount and without wall, you know, without those walls. Because we'd like not to waste time with the solving. Let's check again, for example. Control and the middle mouse, yes? They were here, here, here. I'm looking here for the walls. All right. You know what? Prepare interference. We had 120 interferences 2 minutes ago, let's say. Let's see now how much do we have. Yeah, 116. Let's remove again from smaller body, no? We don't want to cut the floors. Floors and columns are support structures, okay? We can kind of do whatever we want with the walls, but not with the support structures. Ooh, 10. This is very nice. Let me save them. Delete empty components. Source internalize all. I would like to save. Why? Because we will choose the other option. Yes. We have the 10 remaining interferences, but they remained after subtracting from smaller bodies. We will now choose to subtract from the bigger bodies. And hopefully it will not carve up from the floors, hopefully. If they will carve up, you know what? They should take, they should pay more attention in the future and not damage the entire building. Everyone is renovating, everyone producing noise and troubling their neighbors. We all did it at some point. And yeah, there are no interfering bodies. This is what we wanted. Yes? Let's, for 1 second, let's see if there is any question from the audience. There is no question. Mr. Polyuniversum, all right. Let's make those columns, all right. We will start from. We will start from this surface, not this one, but this from below. You know, we don't want the columns to interfere. So let's go here for design sketch mode, and we will have here plan view. Let's assign some columns. Not normally we should. Oh, look, we have some. points. How much should it be? 60, 60 or how much? Support column, let's see, do we have any dimension? Somewhere here. Oh, so generous. 1000. Oh, come on. Why so big? Let's not waste so much material. For example, this one is smaller. We will assign thinner, slender columns because we want to obtain as much money as possible from the new owners. Let's cheat them. So here I see something like 700, 750. Maybe here some dimensions. Come on, please give me some dimensions. You don't want, all right. Support column dimensions. Yes. Finally, we have some dimensions. For example, 40 centimeters, 30 to 80. So something like 50, 60 centimeters would be nice, I think. Let's now not go too far. Here we have. Come on, show me. You don't want. Oh, yes, 60 centimeters. I like this. Square 60 centimeters. Let's, for fun, just for fun. Let's do one. Can we do it? Oh, it's so slender. Should I make it 1000? Let's make it 1000. I want to have safe customers. Come on, don't you do it as a square? Oh no, not that number. Do it as a square, please. I need to stay on the diagonal if I want square. And I didn't stay on the diagonal. Don't want. With tab, we are going to the other dimension. With tab, it jumps. And here I would write again 1000. And I have a proper square. All right, so again, 1000 with tab, again 1000. One thousand. Here. All right, where should we put? How much do we care about our residents? Okay. I'm working in construction at -8 degrees Celsius. I am still working in construction. It's so much sacrifices that I am willing to exert for my customers who purchased apartments from me. I kind of overdid it. I was too generous. Let's make this a column in itself. All right. I was too generous. And when you are too generous, you will remain with very little materials after all. Yes, 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 yes. Maybe here, maybe. Let's do 2 more and we're done. And here it will collide with this whatever this is. But you know, let's still do it. Safety above everything else. I have here. Let's do something like here. Yeah. Is it too much? It looks like too much. All right. So I have all this. Let's go. We now have this surface. Let's hide everything else. Not so much, because I need this. Can I locate in structure tree? All right. I will hide this, the last floor. I will hide the surface. Right-click, invert visibility. Because I would like to extrude these until and more. I would like to bury them. Does it make sense? To bury them. Yeah, why not? So let's get, this is 7 meters, around 7 meters. Support column dimension, buried in soil. I don't know how it's called. Yes, but how much? How much? Give me 90 millimeters. It's kind of small, I would say. Of course, it depends on the height of the building. Concrete footing dimensions. Mean footing size for decks. This is decks. I don't care about decks. Concrete column footing dimensions. Yeah, something like this. Look here. Some of the drawings are, are confidential. Maybe this is why they don't want to give everything. Look, for example, 1,300, for example. 1,300. So this is too little. 2,000 from me. So the dimension from here to here is 41 meters. Let's make it 45 meters, you know. So I will add no merge, and I will say 45,000 millimeters. These are our columns. I don't feel comfortable with only these, and I care for my customers. I would like to have return customers. How much? You know what? It doesn't cost me anything in space claims. So 7 meters it is. I'm so generous today. Show all. Let's make the cutout. Yeah. There are right clicks, source, internalize all, delete empty components, save. There are two methods. The easiest way is interference. The columns will collide, interfere with all the floors. Let's see how it looks. It collided with some walls. 250, come on, it's kind of too big. Subtracted from larger body. Which one is larger? Is it the floor or the column? I would like the column to be intact. So let's do something like this. Let's manually provide the Boolean cutout, the Boolean operation. Combine, and I will say click a target show object. I will select everything but these are columns, all right? Can I rename them? Column? Oh, yes. Let me right-click, move to new component. These are columns. Because I would like to hide them at this point. What are these? This is the walls that I generously provided with no payment to my customers. All right, so here I forgot to. Come on, what is this? Yeah, let's leave it aerated for ventilation purposes. Let's hope the inspectors will not see this, or we will bribe them, you know, in order not to see what I'm doing here. All right, so as I said, in order to perform the combine operation, it asks for the target object, and I will select from right to the left. I will select everything, and it asks for the cutter. I will hide all these. I will show the columns only, and I will select again. These are the cutters. Because I would like to cut the floors and the walls, and I would like not to have interrupted portions here. For example, these columns here, they are not cut. You know, I will show you. They are not cut because these are other colors. Look here. At this moment, I don't know if I need these. Let's leave them. Look here. I will hide the columns, and I have all these, whatever, cubes, kind of like cubes. At least many of them they have square. They have square section, yes. So I can go here and say delete all this. we're left with these. Do I need these walls? I think these are the walls that I made recently. Let's leave them. Delete and hide these and delete this. I would like to have some walls, you know. Walls are kind of important, especially in winter. Yes, the columns are pretty much sticking out, you know. So how do we solve this? I am going to select these faces, for example, search about this. Coincident face. I will select these faces, pull, no merge, and I'll pull until it even of let's drag and drop, you know. So these will be very thick walls. 700. Let's leave it like this. Otherwise, we will prolong too much. We'll extend the FEA too much. All right. So I saved it, and before moving towards the simulation interference, we should have zero interference in principle. Something from the audience? Oh, no, because it's zero audience at the present moment. No problem. We'll make our views or hours. We'll make them after the streams. No problem. Now, there is this thing here. If it cuts, it's cutting. I don't know if it will cut from the column or from the wall. Let's see what is larger body. I will test it. I think it will cut the column, and I don't like this. If it cuts the column, we will select subtract from smaller body. Come on. Did it cut the column? Yes, it cut the column. So Control Z, undo. So nobody is willing to work in construction at -9 degrees Celsius. Let's click here, subtract from smaller body. Hopefully the columns will remain intact. Yes, the columns are intact now. Yes. Perfect, save. We're free to go towards FEA. What I would like to do, because I would like to fix these surfaces here from below, I would like to somehow split these faces of the columns. Let's see how we can do it. Project, maybe? Project, select one or more faces or lines to project. For example, this one. Exit the tool. Yeah, so you look here, yes, I obtained these faces, they are separate faces, because I like to fix them. This is very important. Over here we can see the columns. You know, maybe the new owners will provide something there, something for cover. Let's save it. Then we're going to let's cut and paste it here in our work folder. And here I said something about Seismic. This means let's see how we do it with transient structural. Import geometry here. Copy paste. Rename. And here let's kind of name it something. Stream 13. It's a little anachronic, but let's see. Seismic building V1. Seismic building V1. What materials do we have? We do have the structural steel. Let's apply some concrete. As always, we're aiming for the easiest way in order to attract beginners and to provide a very quick way to do these simulations. All right, let's look for ANSYS building. The geometry is being imported at the moment. Out of curiosity, how they should look like. For example, these are the acceleration or velocity or displacement on each axis. I would like to show you this one. And this is wind, but it's a little similar to the seismic. in shape, let's say. All right. I think this is a response spectrum. Response spectrum. Let's see some loads. Do we have some loads? We have some acceleration here. This is what I wanted to show, yes. So there is this G acceleration. We can use it. Yeah. So let's say from 0, the maximum is plus or minus 1 G, all right? Do we have it's too rough what I said there. 1 G is 10 meters per square second. Yeah, so here maybe it's 5 or 4. So the mean, the average is 3 or 2 meters per square second in order to have like this, you know, this is nicer. So such a load we should apply, you know. All right, so F7. This looks so nice. Don't mind this, you know, for yeah, some construction companies, they're cheating. We should put some drapes here, you know, they will flutter in the wind. Oh, here there is no wall. They should pay extra to have their wall. Here there is no railing. Come on. This is what happens when you pay in advance, you know, and the constructor is cheating. All right. So let's go towards the columns and make them out of steel. They are, because this is default. Let's go towards the walls. Should I name everything as wall? Because we have some floors also. We have floor. Ooh. Floor. So let's do it like this. Wall is wall. Yes. And we have only the walls here. Yes, it's like a filtering. You write and you enter, you press enter. F2 to rename, and you write here wall, and it will give it a number. Then we are going for the floors. So here, enter floor, and we have these floors or ceilings. F2 rename floor. Now if we delete everything, we are where we want it. These walls, I can assemble into I can group them into a folder named walls, of course. And the floors, these floors, I can group them into a folder named floors. And the columns are named, all right? So we have walls, floors, and these are, is this column or what is this? This is a wall. wall, I'll name it wall, and this is wall 0. Wall, I'll put it here, and do we already have a wall? No. And wall 0, all right, in order not to interfere with the naming. Not that it's so important. It's not so vital. I will name these columns and group them in the folder named columns. All right, so the columns are structured still. Everything else I will make out of concrete. If we don't like the stress values, if they are too high, we'll apply some non-linearities. Concrete. Of course, in reality, they are reinforced, but let's leave it like this for this scenario. Connections. I would like to right-click, rename based on definitions, and now everything should be, look, we will not move, we will not touch everything or nothing at this moment here. They should be pretty in contact. There should be no offset. They should be perfectly touching all the surfaces. What I want to do? Let's perform a quick meshing. You know, let's discretize this this model. Oh, almost 900 parts. I'm curious how long it will take to solve. If it takes too much, I will just remove some of the floors, I think. Yes. Look here, some of them didn't mesh. This one didn't mesh. It is a little too coarse. Do we have a feeling about the default element size? Let's see if I can get a feeling regarding the default element size. Yeah, the default is 3.5 meters. 3.5 meters. All right. So this means here I will modify to 2.5 meters. All right. Of course, everything should be hexahedral mesh, and I will force it to be. Let's hope it will be, because everything is kind of square and rectangle here. One part. This is the problematic part, I think. Why is this problematic? It's not a complex geometry. Let's just leave it. Can I suppress this out of curiosity? Oh, and we will have a better view here inside. Let's also suppress. And here, this small wall, whatever it is. Yeah, the owners, the tenants will be furious when they see this floor, but it will be like a terrace, you know? Here I see a problematic wall. Here I see a problematic wall. All right. 2,500 is extremely high. Let's make it maybe 1,000. Right click and suppress all bodies. Let's keep everything. And here, let's make it 1 meter. I'll take a look at my smartphone. Silence. We like silence. Come on. I can try with no adaptive sizing. Let's make this 0 and try without adaptive sizing. 0 means default, and right, we'll make it here. No, no. Mesh defeaturing, yes. Quality, medium. Let's not check mesh quality at this moment. Generate mesh. Given the straightness of the shape of the structure, I will not use virtual topology as I did in the past. I see some green segments here. All right, so we'll revert to adaptive sizing. What will happen if I make here 500 millimeters, half a meter? Yes, except for some of the walls. You know what? Let's save this mesh. I'll make it to impose it hex everywhere because this is tetrahedron. Let's duplicate what we have. This is a good start. Do we have something from the, if there is someone? Nobody. So we have nothing from the non-existing audience at this moment. Who wants to simulate civil engineering Saturday night? Except me, huh? Someone has to do it. I have to give a home. I have to put a roof for the people, you know. I'm very responsible. So method. Let's apply the hex method for all bodies. Control A. Make here hex free face mesh type all quad, and instead of high-5, what will occur if we make it 400, for example? Right click, generate mesh. If I'm going to have a too fine, oh, already 200,000 nodes. This is not funny because it will extend, it will prolong the solving. And this is dynamic, it takes place in time, so. Let's see. Two million nodes? Come on. 2 million nodes. Can I make here a quad 3 to give the possibility to have some tetrahedrons or, I don't know, pyramid elements? Let's see. For a simplistic approach, 2 million nodes is out of the question. We need to obtain results live in the next hour, you know. So 1 million, come on. Come on, come on, come on. What is happening here? I need to accept the fact that there will be some high node count. What is this? Should we shave some of the upper floors? Should we shave them? I would shave this part. And we will have those columns. They will not look nice. All right, so. This is what happens when you don't prepare an extents, huh? Let's right-click suppress body and see. Oh, we have these columns. How do I cut them? Can I cut them without reusing anything and everything? Let's leave it like this at this moment, because I'm afraid I will lose some of the contacts. But you know what? Are they important? Do we care about those contacts? I don't think we care so much. They're default. It's not. I didn't work too much for those contacts. Double click. I will name this hotel V3 smaller. we'll keep only, I don't know how much, 1, 2, 3, 4, 5, 6, 7 floors. It's enough. It's good to have 7 floors. And I will cut these whiskers. So, as I said, let me firstly split body these ones. I will split them according to this face. This face. All right. And now I can just click and remove them. It's very nice that it allows for a selection like this. And now let's just right-click, locate in structure tree, right-click, delete. All right, this is a very nice building after all. We have these walls, holes where the beams were. Should we, yeah, you know what, let's accept this face. Let's do it manually. All right, I will select these top faces from the column, from the columns with Control pressed. And let me no merge. Let me pull them here. All right, in order not to have those holes. So these are our 7 floors. Now I would like to make this smaller. And for example, what is this? What else do we have that's very small? Control S to save. Why did I close space claim? If I would have left space claim opened, then I would have had a faster solving, faster loading of the geometry. Let's see if it ruined my groups, which I carefully created. It's recreating the contacts now. All right, so let's move these here. Let's move the columns. Let's name them. will they, oh no, they will not collide. The columns should be made of structural steel. The floors there are unchanged. The mesh, right-click, rename based on definition. Do we have additional contacts? Let's hope they do not overlap. In order not to have any confusions or doubts, we can delete this. Yeah. And we will create automatic connections, yes. Insert connection group. Yes, we can delete this. Insert connection group. And we will click that connection group, create automatic connections. We can, of course, change these values. Let's at this moment, let's see what we have. We should go towards 500,000 nodes, I think. $854,000 nodes, come on. Come on. Double walls, why? Double walls, why? Why do we have triple walls? Why do we need triple walls? What is this? Can I hide this? Ah. F9 to hide, and this. This is okay. What should I do not to be left with this? With this value. What will occur if I change the feature? How much is the feature sizing? It's 10%. It's 284, around 300 millimeters. 300 millimeters. Let's make the feature size. If we're going here for the element size, it's 50 millimeters, it's 10%. Let's make this 100 millimeters, just for fun. Let's see what it gives. Yeah, it might be the case that I should continue this live stream another time. Why here? Why do I have all these walls? what did they do? Those guys from constructions. Why do I care about this? Well, this wall. Yeah. We can try and do something like this, you know. We can try and obtain one concrete part. Let's see if I dare to do this. Let's try and merge the entire concrete structure. I will try and merge it into one part, and we'll leave only the columns separate. This would help also not to have thousands of contacts. So let's right-click hide, and here, why is this here like this? Why? Design, pull, no merge, up to here. All right. I would like to select small walls, if I have small walls. For example, let's see. Small walls. Where do I see small walls? Of course, small useless walls, not small important walls. For example, this one. Why do I need this? Let's go here for selections, search walls, and I will delete these small walls. All right. Let's select all of these, combine. If I have everything that is made of concrete, if I have it as one part, then it will be extraordinary regarding the meshing and the contact and everything. Maybe there will be also mesh troubles. Let's see. We will see. Oh, it's so nice. Look here. This is what we need. Yes. Show all. We have the columns. We will have bonded contacts as usual. What is this? Out. Right-click, delete empty components. We have a floor here. Yes, this is, what is this? This is a wall, and this is another. What is this? We have a wall here. I don't care, and a wall here. All right. So this gets out. Yes, ventilation purposes, you know, because I would like to have only two. This is the concrete and the columns. Right-click, delete empty components. Complete, save. Let's leave it open. And here, right-click, update geometry from source. It should load very quickly because I have space claim opened. Yeah. So I want here v3 smaller. Let's leave it like this regarding the naming. It looks so nice. Finally, it makes much more sense. All right, so this is concrete. Can I get it out? Remove from group. Building. This is the building. This building is made out of concrete. These columns should go here. The floors don't exist anymore. The columns, what? Should go here. And we delete the walls group because it doesn't make sense. The building should be concrete and the columns structure steel. All right. Now let's go for the fun part. Let's suppress this just for fun. I will make this default and let's try. Let's see what the measure says. I left the feature size 100. I might be forced to delete it. Come on, mesh, mesh, mesh. Oh, yes. Oh, yes. Hex mesh. Yes, you know what? I am satisfied with it. Let's duplicate. We have mesh. From now on, we can do FEA. I can close space clean. Do we have someone? Yes, there is someone watching. Hey, bro. Hey, bro. So we have a salutation. Meters per square second. All right. My first attempt will be to assign such peaks, and yeah, let's see how it works. So how many? 162,000 nodes. This is already much. The default was around 3,000. Let's make it to 2 meters, the default. Let's see if how much will it go? Will it go towards 300,000 nodes or not? I should have put a column here. Let's hope it will not be a problem. It's pretty nice. The columns are pretty coarse. What is this? Oh, it's a recess. Okay. Just out of curiosity, can I hope to make this hex dominant? if we leave such big elements, it will the nodes will never meet. Yes, we need these nodes to meet these nodes, and it's kind of absurd, you know. We need to impose a pinball radius, a big pinball radius. So this is why we need a finer mesh after all, you know. I will refine the mesh in the columns separately, I think. Let's see how it looks now. Yeah, the conversion from tetrahedron to hex is takes much time. Come on, do it. I can go for not for a sweep, but for a multi-zone mesh. Let's see. Multi-zone. I'm sorry, okay. Free mesh type. Should I allow some free mesh type? Let's say hexadominant. Surface mesh meta. Let's see like this. What will it say now? Do it. At least give us a sign, at least. You don't want, huh? All right, let's, if I select not, I can select tetra. Let's see if it works with tetra. So we should remember, if we have such recesses like here, some grooves and channels, and then we will have problems, you know. Here we have problems when we want to obtain a coarse mesh. So this is why you need to always pay attention. Since the modeling stage, we need to pay attention. All right. Tetrahedron it is. But the main question is, how coarse should we leave it? Should we leave it like this or not? You know what? At this moment, Let's leave it like this. I will select the columns and make the sizing maybe 1,000, 1 meter. All right, 500 millimeters. I'd like for the nodes on the columns to find the nodes on the floors and the walls, and yeah. To ensure that such thing happens, let's assign some pinball region. Let's go for auto detection value. Yeah. All right. So my dream was to have something like this, of course, not so detailed. So instead of 20 seconds, let's make it 5 seconds, and let's make something like this, some peaks, all right? 5 seconds. This means what I would like to do is I would like to work with more steps, 5 steps. This is 5 seconds, all right? Initial time step 0.1, minimum time step 0.01. Come on. 0.01 and maximum 0.2. All right. Carryover time step on. Why it doesn't show on? We don't know. All right. Solver type. I like to select direct here, and let's see if we have. Do we have acceleration? We have acceleration here. Let's select one axis, and the axis should be this one, x. Yes, this one. This one, something like this. X components, x-axis. And I said that the range is between, I don't know, maximum 3 meters per square second. So let's go here for tabular time and say from 0 it will go to a peak of 2.5. Then it will go down towards -2. Then it will go up towards 1.5. Then it will go down towards -3.5. Is it? You know what? Let's kind of cut this or paste it from 0 to yes, -3, from 1.5 to 2, from -2 to 1.5. We have something, all right? And we will fix the faces that did I lose the faces? I lose the faces. When I remodeled in Spacelab, I didn't take into it. I don't have the separate faces. We don't care so much. We have here for both slides, we'll select the ends, and also this floor. All right. I think it's kind of the same, but let's work with what we have. Or maybe we will. I will suppress this. Let's see. Let's see what it is. Solution information, deformation, stress, and strain. Switch to automatic mode. Solution, deformation, total. We have velocity and acceleration. Directional acceleration, and velocity I would like to be also directional, because we know it's on the x-axis. Strain and stress. All right. Here, maybe 50 cores, just because I can. Any question from the audience, if there is someone? No question. The same salutation. All right. Let's see. Solve. If it goes very fast and it solves quickly, I'll make a final mesh. But at this moment, I would like to get an idea of the tendency. Yeah, it looks very nice. Maybe I will also change the style to nonlinear. Force convergence plot. Green vertical lines, we have convergence. And we can take a look here to see the intermediate results. Ooh, yes. Auto scale. Let's make it 1. Yeah, it looks very nice. Let's also see some stress values. Having such coarse mesh, we have such a plot, 0.005. Oh, yes. So the files will be available upon request. They will also be uploaded on expertfea.com. So you will be able to refine the mesh according to your needs and see the difference that it makes towards the stress usually. You can perform a sensitivity study refining the mesh and see the value that it approaches. We have higher values, please. Show higher values. Oh. Maybe I had applied too small value. Uh-huh. I would like to see displacement plot, instead of the acceleration one. Because after applying acceleration, I don't have realistic values for stress. Seismic displacement, relative displacement. Oh, yes. What is this? Relative displacement at top and bottom of the tunnel. This is a tunnel. I would like to have a building, not a tunnel. Here, this is interesting. This is a good plot. So we have an average between 0.05 to 0.1 meters. If I don't like what I have here, then we can also apply displacement, no problem. Take into account that this is one way of defining seismic load for a very quick solution. Then I will apply also displacement instead of acceleration, and we will see the difference. For example, the deformation that we have is so small, so I think this acceleration is not reliable. I know the problem. Now I know the problem. I have defined on millimeters per square second. I'm wrong with the scale. Yes, let's pause it. I should multiply with 1000. This is why the values were so small. This is why people have left the chat, the audience, because they have seen that I mistook the scale. Yeah, so because I like how it looks like, let me duplicate it. I will write here a wrong scale, if possible. Yeah, duplicate. So it should work in principle with acceleration. If it doesn't work, we always have displacement. A seismic load is defined by displacement, velocity, and acceleration. All right. So no other message because no one is present except me. Someone should put a roof over the heads of people, so it's me at this time, Saturday night. All right, let me multiply with 1000. All right, and here 1500. Now we should have, yeah, kind of 1000 times resulting deformation, 1,000 times the resulting stress. We have linear materials, so it should scale up 1,000 times. Yeah, we need a coarse mesh in order to achieve results live, on the go. It converges. We're very happy. Yeah, let's look a little at what our other colleagues have made. This is everywhere in the tutorials. This is my most viewed, I think. Even though it's pretty primitive in the trial, it's very well viewed. It's the second. My top viewed is the compression of chest with the leg kicking on chest. This is my most viewed clip. All right, this is interesting. Even though it's mine, I will show it to you just to see how it behaves with the seismic cloud. And this is a reinforced concrete. These furniture objects, they give so many problems. They stopped the FEA. Yeah, I know it's a coarse mesh, but yeah. These are force reactions. Here, what? Total deformation again. Some vectors. Yeah, I'm sorry because of the resolution. I don't make the software. CFD, ANSYS. Even though it's just a column, let's see how it's done. It's a model, and it's like this. It's not with line bodies, so it's not a reinforcement. It's like a steel structure. So I would say pretty basic for my taste. This is using, I think, line bodies. Yeah, it uses line bodies because we see this. Look here, we see line bodies for the columns. And also in the mesh, we see this interference. Some patches, these are from the line bodies. A problem here is that he didn't unite the line. There is like an option in SpaceClaim to unite the vertices and the lines. So this column should be one column, yes, not separated. So in the end, there is, when you access workbench, I think, there is this option of uniting. Let's see if I can find the workbench toolbar SpaceClaim workbench toolbar. No, I cannot see it here. Do we have something like all the toolbars somewhere explained? No. Yeah, let me open the SpaceClaim software and tell you, yeah, so he has obtained various columns or beams, and instead it should be one. This is my opinion. Oh, it's only the first second. Out of curiosity, because the time step is, the time increment is 0.02, so small. I was wondering if I can force this to increase. Yeah. Nevertheless, I will continue solving offline, so we'll be content with what we see here. Because my aim is in 10 minutes to finalize the stream. Yeah, finally better values. And here, for the stress, come on, show me 10, 20, 30 megapascals. Please. Right-click, adjust to visible. Yeah, this is better. Yeah, the plot is dependent on the mesh refinement. So as I told you, there is this here, the share coincident topology. He didn't do this, the share. This is my opinion. I'm talking about this colleague. Nice work, yes. Does he have results? He has no results. Come on. Maybe here? Does he have results? Yeah, but you know what? Dear Abby Innovate, you just model, you don't simulate, no? This is also taken from a book, I think from Hui Huang Li, I think. This is also something like this. Yes. Nothing new to us. Building ANSYS. Oh my God. So much AI here, so much artificial intelligence. Reinforced. Concrete. Come on. So this was so many times uploaded with no additional benefit. Building better boundary condition. Does he have results here? Yeah, let's see. Oh, he has results, finally. Yeah, this is how you see the diagram. Kind of the same thing over and over again. This is interesting. This is something I read a few years ago. Yeah, it's not the most extraordinary thing. Maybe it's cute for Minecraft players. Yeah, it's better than nothing, you know. I think you're right. This looks very nice. Maybe these are some columns, maybe. Yeah, so exactly 2 seconds. All right, to each his own. Yeah, it looks nice for a beginning. It looks nice, you know. Yeah, I hope you learned something today. And yes, it can be optimized. It can be treated more, and stay tuned for more simulations, for more lessons. They will gradually advance, and it will be more. I will present more complex scenarios in the next live stream. So thank you for your attention, and I will see you on the next live streams. Bye bye.